Hello and welcome to today's Tech Talk Online, focusing on measurement solutions for grinding, turning and special purpose machines. My name is Uwe Fischer. I work in the technical sales department at the Blum-Novotest GmbH in Grünkraut, where I'm responsible for various manufacturers of turning machines, grinding machines and machining centers. In our Tech Talk Online on high-speed probes and turning processes, my colleagues already told you all about the extensive range of Blum probes. The information provided mainly dealt with applications that use wireless probes with infrared or radio transmission. Today, we'd like to take a closer look at applications that use hardwired probes, for example grinding, turning and special purpose machines. Let's now move on to the running order of today's event. First, we want to inform you about the TC76 technology, followed by interesting applications for the TC76N switching probe and the TC76 Digilog scanning probe, before giving you a brief outlook on roughness technology, which will be discussed in more detail in a separate Tech Talk Online. Finally, we'll present our new high-precision SE050 swivel unit. Our TC76 probes with the patented Shark 360 measuring mechanism are ideally suited for grinding, turning and special purpose machines. I'd now like to take a closer look at their technology on the first slides. The probes are equipped with a standardized M16x1 interface. Due to their immersion-proof design, they are ideal for harsh conditions in a machine environment. With the TC76 probes, the trigger signal is generated via shading of a miniature light barrier. They are therefore not mechanical switches as widely used in the market, meaning our technology features were free optoelectronic signal generation. The probes are characterized by their precise, non-lobing touch characteristics, the torsion-absorbing face gear and offer constant measuring forces in all probing directions. The TC76 probes are perfectly suited for the fastest measurements up to measuring speeds of 2 meters per minute. Further, there's no risk of phantom signals at high acceleration rates. Due to the measuring mechanism, they are also ideal for pulling measurements with an offset stylus. They are perfectly adapted to the harsh machine environment and offer precise measurements even with coolants. The TC76 probe is available as a mirror switching probe, as a probe with an additional analog signal, for example for scanning surfaces, and as a roughness gauge for surface inspections. We'd now like to explain these applications to you in more detail using various application examples and videos. The initial application shows the TC76N probe being used in a profile grinding machine for workpiece measurement and workpiece 0-point measurement, typical measuring tasks for such machining operations. In this case, the TC76N probe is positioned on a custom linear unit. In the video, you'll initially see the probe being used for workpiece referencing, followed by the actual grinding process. Finally, the dimensional accuracy of the workpiece is checked. Loading and unloading with the aid of a robot characterizes the increasing trend towards partial or full automation, in which process control, for example using probes, is also becoming more and more important. In this application example, watch the TC76N probe being used for internal cylindrical grinding and internal grinding. The probe is mounted on a base next to the grinding tool. Using the linear axes and the rotary axis in the workpiece spindle, it's possible to determine the workpiece 0 points and to measure lengths, diameters and distances. This machine boasts a very high coolant load, which is over 100 bar in the machining area. Due to the immersion-proof design, including a double sealing diaphragm, the TC76 probe was built with such harsh environments in mind. The next video demonstrates how the workpiece can be calibrated in a surface and profile grinding machine. In this application, the TC76N probe is mounted directly on the grinding spindle and is swiveled to the measuring position by the spindle. The probe is used to determine the exact position of the workpiece, thereby ensuring its correct machining. The specially designed stylus of the TC76 probe, which is adapted to the said application, is clearly visible. The use of special overhang styli that are attached vertically or at other angles to the stylus shaft is also very common. Quite often, pulling and pushing measurements are also performed, for which the shark measuring mechanism of the TC76 probe is ideally suited due to its face gear. Moreover, the non-lobing touch characteristics with the same measuring force over the entire circumference are also advantageous. Due to its robust design featuring the shark measuring mechanism, The TC76 probe is also ideal for horizontal use with longer styli that have a higher net weight, as you can see in this application example of a grinding lathe machining center. There are no erroneous deflections caused by the net weight of the stylus. When using the hardwired TC76 probe for workpiece measurement in harsh environments, for example machining hardened materials, the probe and especially the stylus can be additionally protected by our pneumatically controlled protective sleeve. This protective sleeve was showcased in a previous Tech Talk online for tool measurement with a cube-shaped stylus. It can, of course, also be used with a ball-shaped stylus for workpiece measurement. The increasing level of automation and accuracy in machining operations results in a higher demand for measurement technology also for robots. Furthermore, the TC76 probe is equally well suited for use with a robot arm due to its robust design. The high acceleration rates do not result in erroneous signals. The standard version is suitable for accelerations of up to 5G, while the reinforced version can withstand up to 20G. As shown in this example featuring the highly dynamic measurement of cams at a measuring speed of 3 meters per minute in this case, the customer even exceeded the measuring speed of 2 meters per minute originally recommended by us, thereby proving in a real-life application that you can always extract a little bit more out of Blum components. It's now over 10 years since the TC76 probe was further developed as part of a customer project from a mere switching probe to a probe that can additionally output an analog signal and is, therefore, suitable for scanning surfaces, for instance. This probe has since been available in our product range under the name TC76 Digilog. The next application example shows a typical application for the TC76 Digilog probe in a gear grinding machine. The blank geometry and position are recorded by the switching measurement, followed by the profile and flank of the gear while being scanned using an analog process. The TC76 Digilog probe is positioned here on a custom swivel unit. Through use of the analog signal, an additional interesting further development of the Shark technology occurred. The use of a special stylus allows you to gauge the roughness of a surface. These probes have the abbreviation RG in their name. Learn more about the possibilities of this technology in a subsequent Tech Talk online. An extensive range of accessories is available for the TC76 probes, including various bases, extensions, elbows and the aforesaid pneumatically controlled protective sleeve. This guarantees flexible adaptation to your requirements. As could be seen in some application examples, it is often necessary to use the probe on a linear or swivel unit, especially for grinding and turning applications. I therefore like to draw your attention to our new compact, high-precision SE050 swivel unit, which boasts a positioning accuracy of plus or minus 1 micrometer at both end positions. There's no typical resting or measuring position with this unit, as both end positions can be used for measurements. With regard to the arm design, it can feature standard components such as extensions, or even a custom-made arm. Here you can see another application of the SE050 in a turning machine of the Blum Mechanical Engineering Department. The arm was designed with standard components, in other words using extensions and an elbow. First see the resting position above the opposed spindle and then the measuring position in front of the opposed spindle. This allows tools that are positioned in the direction of the opposed spindle to be measured on the turret. Your local Blum sales representative will be happy to provide you with further information. I hope we've been able to give you a compact overview of our measuring solutions for grinding, turning and special purpose machines. We now look forward to your questions. You'll find our contact details in the video description. Thank you for your attention, and we hope to welcome you again soon to further Tech Talk online events featuring exciting news about in-process measurement technology.